So in this video, I'm going to explain you what is the reentrancy attack. So what is reentrancy? Hello everyone. In this video, I'm going to show you what is the reentrancy attack. So in order to depict this attack, I use a pseudocode, and I explain you by making two simple sample examples. Hello everyone. In this quick video, I'm going to show you what is reentrancy attack. So reentrancy is a smart contract or contract to contract type of attack, and this is quite popular for the Ethereum ecosystem. And this is very similar. It's related to the atomic behavior of statements. Hi everyone. In this video, I'm going to explain you what is the reentrancy attack, which is a popular attack for the Ethereum ecosystem for the smart contracts. So let's show you how it works with basically a simple snippet code. So for the sake of simplicity, I'm gonna write this in type of pseudocode, but hopefully you understand that. And if you have any question, you can write your question in the comment section below. So let's suppose that we have a treasury contract, smart contracts that receive funds from the different third parties, different users, clients, and hold their funding and do some stuff with that and allow them to withdraw their fund. Okay, so let's call this contract fund manager, something like that. This is a pseudocode. This is not a Solidity statement, but if you are more interested, you can check out the link in the section below. I put my GitHub repo and the repository of this code, in addition to a real life vulnerable piece of code that represents the reentrancy attack. So the contract fund manager holds some funds, and let's say the total fund would be, or the fund would be like 1,000 Ether. Okay, this is what we have. And it also allow other people to withdraw their fund, other clients to withdraw and take back their basically deposit here. So I call this like function withdraw, a simple function. I mean, this is just a pseudocode just for the sake of education. So what does it do? So it checks its fund, and when it was more than, let's say, 0, then it transfer the fund, allow other people actually get the fund, or get back their fund, and then send let's say Ether, and it send just based on a request, send 1 Ether each time that an external contract invoke this method here, withdraw method. And after doing this, it updates its statement. So it says, okay, it updates its actually current treasury. Say, okay, fund would be fund -1. So here it received the fund, and then it send the fund when it's more than this, and then just remove that fund from its treasury. That's the whole thing. Simple logic. Then on the other side, we have one of these clients or contracts, which is a malicious client, and try to perform reentrancy attack. Reentrancy attack. So in order to do that, we need to craft a malicious and attacker contract. So we call this contract attacker contract here. So attacker contract, define some funding. Say, okay, local fund, and let's say local fund is just like 0. And then what does it do? It says design a function to do some stuff here, or say, okay, I have contract fund manager So, okay, so in order to perform the attack, it has to invoke, so in order to perform the Reentrancy attack, it says, hey, I want to withdraw my fund. So what does this attacker contract do? So first say, okay, I want to take advantage of this function, and I want to withdraw my funds. So I said fund manager and withdraw. So I call this function here to get back my funding, okay? And I do have like one, for example, Ether there. So it seems to be okay. It seems to be, normal so far. I have 0 fund right now, and I want to withdraw my fund and take back my 1 Ether from fund manager. Fund manager, I agree that, check out, it's, treasury. If it's matched, then it send me 1 Ether, and also remove that from its funding. And then I don't have anything there. I don't have any records. That's the logic here. So what actually happened, I mean, if you pause the video and think a little bit about that, if we can somehow interrupt this statement here, line 16, and do not allow the fund manager contract to update its record and funding record, etc., then we can actually do something. Then we might be able to actually steal the whole funds from the vulnerable contract here. So if you remember, I mean, if you're familiar with computer science stuff like operating system, this is more like, how can I say, it's more like deadlock type of situation, because contracts are on the blockchain and presumably other contracts can invoke them. So we might have some kind of, deadlock situation, which is rely on the atomicity of operation. So since here we have 2 statements, if we can somehow interrupt this one or get around this one, then we can actually withdraw contract. We can take more tokens without losing anything, without losing our track, on the fund manager. So the trick here is how we can do that. So in the Ethereum ecosystem, we do have a concept of fallback. If you remember with Node.js and those type of languages similar to that. So fallback is a default function, okay, in this ecosystem. So when it gets actually invoked, whenever we receive some interaction from external contract, because when it sends the Ether here for us, it actually call our contract, say, hey, I send you Ether, so do whatever you want. So some people, normal developer, they just log this and say, I've just received my fund, my Ether. Okay, this is what some developers do for debugging and so forth. But what we can do as security expert, we can actually go to fund manager contract and invoke the withdraw function again. Right? So by doing this, whenever it sends the Ether for us, we receive the Ether and we go by default to fallback, and fallback locks something and then invoke this. So before it has this fund manager contract has any chance to move to the next statement, actually we invoke again the same function and we go here, and because our records hasn't been updated yet, then it get actually executed again and again and again and again and again without any updates on our side for updates regarding our basic records on the fund manager side. And this is how we can actually skip this one and withdraw the whole funding from the fund manager contract. So this is actually quite popular and type of iconic attack, especially for the Ethereum ecosystem. So I hope you enjoyed this video, and if you find it informative, please don't forget to subscribe, give it a like button, and write your comment in the section below. Thank you, and bye-bye.